Good morning. My name is Marcin Krzyzanowski and I'm here today to talk about CoreText with all of you. And so I will be doing some presentation with slides, then I'm going to get into some coding and I show you how CoreText is structured and how to play with it. Then at the end there will be some time for questions, so you can ask as many questions as you'd like and I will answer as many of them as I can. So let's get started. I already said my name. I'm Marcin Krzyzanowski, so you can find me at Twitter at this handle. Feel free to reach out on Twitter, email, GitHub, anything. Just check out my website. So first, I wanted to talk to you about why CoreText. Why would someone use CoreText instead just UIKit components or AppKit components? CoreText is a text layout, shaping, rendering, and even fonts management library. It's available both on iOS and macOS and on any Apple platform, although some features are available or restricted on one or another platform. In general, CoreText on macOS is the most full-featured, especially when it comes to the font management. But other features are almost equally available across the platform. What are the alternatives to CoreText? Well, obviously, there's a text kit that is part of the iOS and macOS SDK and system libraries. You may be most familiar with the text kit components. Comes the UI text view, NS text view, NS text field, and so on, NS layout manager. Those are the components of the text kit. It's really good framework. It's a high-level framework, very full-featured. Available only on Apple platforms. You can use Harfbus, which is the library for text shaping. This is not Apple library. It's open source. It's very good. You can use FreeType, which is the font rendering library. You can use font config for font management. This one is used on Linux everywhere. And there's Pango. Pango is like a more close to CoreText, which is the text layout and rendering. It uses the other libraries. On Windows, there's Uniscript, that is probably the most similar to the CoreText as far as I'm concerned. So API. The CoreText API is not very rich, although it's very powerful. Here I listed I think all the types that you will deal with, and in this talk I will mention and describe to you just a few of that, but the most crucial, which is city font, city frame setter, city line, city run, and city typesetter. There's also city font manager. I would like to cover this part, but it's very broad topic, and font management can be complicated, and this won't be part of this talk. Let's start with how the CoreText works, because the CoreText is a text library. We need to know what surface we are, what is the canvas we work with. And so what are the coordinate system? What is the coordinate system? On iOS and macOS, the coordinate system is different. If you come from iOS ecosystem, you're familiar with this top left origin of the coordinate, but on macOS, you're more familiar with the bottom left origin of the coordinate system, and this one, the latter one, is used by the CoreText as well. also by the core graphics, so you may be already familiar with this one. Then there's drawing. For drawing, CoreText uses a core graphic framework. You're familiar probably with the core graphics. This is the framework we use to draw shapes and some other things. I just mentioned here some of the API. As you can see, Core Graphics has these outlets to draw text or some parameters of text, like set font for the context, graphic context, set text matrix, set text position. Same with the CoreText. CoreText has few functions that get the core graphic context as a parameter to draw on in that context, like cityline draw, city rend draw. We will discuss those later. The most important is, because we work with the text is built of font, and to lay out a text we really need to understand how the font matrix looks like to lay out it properly. So that will be, this is the image you can find in a CoreText documentation, and is sufficient to do all the calculations you will need, and we will use later in this presentation to lay out text properly. As you can see, there's a baseline. Baseline is not on the bottom, it's a little bit upper. A baseline is like bottom in rectangle, but it's not bottom. Baseline is the line that the font designer uses as a base for all the glyphs, all the letters. This is the most important. Let's try to build a label. You know what the label is? The label is like a UI label from the UI kit, NS text field from AppKit, or text from Swift UI. So it's just a text. The text can be short, it can be long, that can be wrapped or can be truncated, and those are the features of the label, and this is what we're gonna do with the CoreText. As a skeleton of our label, I will use the UI view for the purpose of this presentation. But almost the same apply for the NS view if you're from macOS, and you can use all these informations to build the label in a Swift UI. I did that. Maybe I will share a link to some GIST in the notes. We have a UI view that has initializer and draw. Draw function is the function that is called by the UI kit framework to draw the content of the view. And this is where we will spend most of the time during this talk, in draw. First approach, I have a draw function. I get the graphic context, current context. Let's say I add a text property to our label, so we have a text to draw. And you may probably be familiar with this one, which is NSString has a function draw, which draw its content at the given position to the current graphic context, and that's it. That works. You will get, we will get text, but that's not really what we're here for. And also you can see I made this presentation in Keynote, and you may notice how the background to the letters is draw. It didn't draw properly, so I hope that after this talk you will know how to do it properly. Let's go and start with the CoreText. In the CoreText, most of the time we deal with the two structures. One is attributed string. Either this is NS attributed string or CF attributed string from Core Foundation. That's the one there's bridging, so we can use interchangeably. And this is a data source. This is a storage of our text. Then there's CTLine, and CTLine is most fundamental type that is used to lay out a line of text of string. And here I create a CTLine instance out of the attributed string, set the text position on the graphic context, and call CTLine draw CTLine context, which means draw this line on a given context. And there we go. We have something, but it's not necessarily what we may expect. I expect the text, but instead I can see only these few dots. My text is hello world. Well, okay, let's see. It's obviously something is truncated, so here I just change the Y value by 100 to just randomly move it, and I see this hello world, but it doesn't look right. It's upside down, and it's not really at the position. Well, it's 100, so it's some position. How to fix that, and why it's happens? Wait, this happens because we're in a different coordinate system. CoreText has its coordinate system, CoreGraphic has its coordinate system, and UIKit has its coordinate system. To adjust one to another, we have to transform text. Here, there is a text matrix property on the graphic context that I use to swap the Y value. So instead of getting top to bottom, it goes bottom top. And yeah, so the one on the left looks right. So I can see hello world, and it's not upside down, but still there's something missing. It looks like a truncated at the bottom, and it looks like a truncated at the very places we've seen previously. So there's something into it, and that something is the decent value. So you recall the baseline and the text position. So the text position text on the baseline, right? If I put the text on the bottom, that means there's still something below the baseline that can be drawn at this part of the letter, but can be truncated. So what do we have to do? We have to adjust the text position by this lower part of the font. How do we get that? We use one of the CTLine function. There are three of them. There are three of them. You can check all of them in the documentation. This is the one you will use most of the time probably. CTLine get typographic bounds. And here we get three values, ascent, descent, leading, but now we only need descent and leading. Descent is this bottom value, and leading is line gap. Most of the time it will be 0, but it doesn't have to be, so you have to take that into account. So now I know this bottom value, and I just subtract from height and move the text position. Ta-da! Looks pretty good. So the hello world is now properly drawn on the bottom of our label. But what will happen if text is longer? So now we have this example of very long text. Hello world is very long and blah blah blah, and it's not really truncated nicely. So in the middle of the E, it's not really truncated at all. It's just where the view ends. It will draw, continuously, but this is where the view ends. And how we can do with that? So we have two approaches to that. We can wrap text or truncate text, and the truncate text CoreText can help us with that. So to truncate, we first create the original line, city line. Then there's a token. The token that is used in the place of truncation. So it can be at the end, at the beginning. Now, in our case, this Unicode 2026 is ellipsis. So I created a token that is a string, attributed string, it can be anything, and use the magic function cityLine create truncated line. Out of the original line, create a truncated line, truncate line at bounds width. In our case, locate the token at the end and give a token. And this is how it looks. So it looks pretty good. You can see the CoreText take into account letters, so it do not truncate in the middle of the letter. We have lar and ellipsis, so it looks good. But what about wrapping? So if we have a longer text and we want to wrap, so it will fit in our size. Here, let me introduce you the city frame setter. The frame setter, originally like a word, is about somebody who put the letters together. So city frame setter is a special frame setter that comes with CoreText and will do a lot of magic for you. When we work with the city frame setter, there's also city frame. They work together. The city frame describe the frame, and the frame can be anything. Here I created the frame setter, then I created frame out of the city frame setter, and the parameters are first the frame setter, then the string range, because I can use any range, and there's a shape, which is the most important, a CGPath, you can see, and I can choose any shape I want. A shape is the shape where the text is enclosed in. It's the box, but it's not necessarily a box. It can be a rectangle, it can be triangle, circle, something like that. Any shape you want. Once we have a frame, we get the lines out of it. City frame get lines, give us the lines that using the city frame setter you've built. So all layout happens, and we already get the lines that are wrapped properly. There's an example of shapes. It's just an example. You can really play with anything. You can have multiple frame on the same view. So yeah, it's very powerful. Yeah, so I've got the lines. This is on the first line here. I have lines, and I have to draw those lines somehow. To do that, I use a city frame get line origins. That means give me the position of each line, so I can use that for the drawing. So I have lines, I have origins, and in the loop here I draw each line one by one, text, position, and line. And look what we have. Hello world is very big and the ocean is very large, but large is at the top, but it should be at the bottom, right? This is the left, right, top, bottom text system we use here. So it's not really expected, is it? What to do, how to do, what happened? Well, it's wrapped properly. It's just the origins are not in the right order. As you can imagine, you probably know that it's again about the coordinate system. We have to transform origins from one coordinate system to the other one. Flip the Y, right? If I do that, there we go. First, the text starts at the bottom, which is correct. The second one, it's properly wrapped. If we have an opportunity to change the width of the label, it will update, recalculate the frame, and the wrapping will update. So it's pretty awesome. So we have a label, basically. Okay, but the CoreText gives us a bit more control over what's going on. So let's see what actually happens when we draw the line. A line consists of runs of styles. That means internally it is divided by the ranges that have the same set of attributes, and it is called run. I call it style run because I believe this is more the easier to understand. So using the function cityLine get glyphs runs, give us a run, and there's convenient function draw city run draw. Draw this run in a context and range. See, there's the word glyphs. Glyph runs happens here. That means we already start thinking not in a letter like ABC, but in a glyphs. Glyph is a shape, more of a shape that comes out of the font itself. After the all the Unicode and stuff logic applied, we end up with a glyph or set of glyphs that represent a single character. You go deeper. What happens actually in a city run draw? We draw glyphs. This loop we had just before. So there's a style run, and well, I can get all the glyphs that happens to be in this style run with using city run get glyphs. Then I get the positions for each glyph, like city run get positions. Then I have access to the attributes. Those are the NS string attributes, but not only. You can use any attribute. So I get here, I get the font value because I need a font to draw glyphs. I know what the glyphs are. Glyphs are represented by a number, but to get a shape out of the glyphs, I need a font. So I get the font here, and using the function cityFont draw glyphs, I draw glyphs on the positions in the current context for given font. Okay, let's go a bit deeper. What actually may happen in cityFont draw glyphs, but there are shapes, so we draw path. The top of the function is the same, but I replace city draw glyphs with what may be inside. So what do I have here? I get the cityFont CreatePath for glyph, which means create a path. Path you can you are familiar with from CG graphic, CG context, which is CG path, basically. So I have that. I apply the transformations and I add path to the context and fill path. So I basically draw this glyph. At this point, if I'd like to, I can customize the path to do anything, like colors, like it's up to me. I'm on a pretty low level. Okay, let's go a bit deeper even with a custom layout. Use the frame setter directly without city frame. Okay, this is a new example just for this slide. How I can lay out text like naively. That would be here I created 3 lines. It's line 1 to 3. I start at the Y position 0. Then I loop over the lines, draw each line, and move the Y position by line 8. But what is the line height? We don't know that. So to get that value, I use the function I mentioned already, cityline get typographic bounds, which gives me ascent, descent, and leading value. That is the line. And I increase the y value by this line height. In the text position line, you may see that I only actually increased by ascent value, which is the top value. This is because, again, I'm here in this example, I'm using the baseline as this y value. But it is a bit tight. If we compare that output with what comes from the city frame setter in city frame, you will see that the lines in the frame setter has a bit more space between, and this is something that is implicit, and the value is 20% of the line height is to separate each line. This 20% is the value that comes from the history of typography, and it's used as the base value to separate lines. When we work with attributed string and so on, we can change that value. There's a property, and this attributed property that we can adjust that value eventually, but this is the default. I go deeper because that was the naive approach. Now let's use the actual typesetter that the CoreText gives us. So I have a typesetter instance created from the attributed string, and then I have a line. I create a line by the typesetter. So it says, okay, hey typesetter, give me a line for this range, and then I draw the line. That was the naive. This is the more full feature example. This example includes word wrapping, but it's manual wrapping. What happens here? I have a typesetter. I loop over all the characters. I start at the character at index 0 and go up until the end of the attributed string. Then I find where typesetter suggests me to break the line, and this is the city typesetter suggest line break. And one of the parameters is bounds width, which is the end of our label. So this is the I say, okay, typesetter, I have this width, I have this point when I would like to break the line. What do you think? Give me at which character it will be. So it gives me the character index. Then I create the line from the range before the break, calculate the line height, and draw the line. In this loop, it will draw all the lines, so we'll get all the breaks. Right? It's more complicated, but you know what's going on, and you can use that to build more sophisticated logic behind breaking text in this example, or layout text. As we have this layout text and we have the width, I said that there's a size that the typesetter gets into account to calculate the bounds, and so the common task is to actually get size that will fit a given text, and there's a lot questions about that, how to do that. There are several functions that you can call. There's a function cityFrameSetter, suggest, constraint, something like that. That will work most of the time, but if you browse the Stack Overflow, you'll find out that this is not the ultimate answer. There's a bug somewhere in this function that it will fail, and it will report the size that is not high enough. The function I use is this one, get size that fits. And this function can be used by the label as well. So what's going on here, I use the knowledge I just learned, and I use the frame setter, and I say, okay, my shape is huge, it's very tall. Then I calculate lines in my way, like this typographic bounds and 20% of line spacing, and I go over all the lines, and at the end I have the last line position. This is how I calculate the size. You probably will need that kind of function when you build a table view with the automatic height or sizing or something like that. So I found it interesting. But there's more in the CoreText. There's more that we won't cover today, but I encourage you to go through the documentation and look there. So there's font management, and this is a whole new topic, very powerful. There's font descriptor, which is the part of the font management. Font descriptor is like a builder for the font. There's more font measurements that you can use, like a XCAP, which means you can get the letter that is designed to be small, capital. I'm not sure how it's called. There's a support for text editing, even like caret offset. So you can ask CoreText, where should I draw or put the caret that will be placed before the letter, right? There's an API for that. There's an API for alignment or justification. And there's really more. One more thing, pixel perfect drawing. Since we use a core graphic, you may find a situation when after you calculate all the values, line width, line height, like spacing, your lines will misalign. So you will think, okay, this is anti-aliasing, something like this. The shape is not sharp enough. I'll give you an example. So let's say you have a text and you draw a background around it. And this background you calculate from the text position, which is city line position. So you get the height of the line, right? You can draw the background, the rectangle. But you will probably notice that this shape is somehow blurry on the edges. And what happens is, this is normal in core graphic because core graphic values are not pixel rounded, pixel perfect. You may have heard that the Swift UI gives us the pixel perfect drawing grid, like positioning, but otherwise we have to do it by ourselves. And the same apply to text. All the values that we get from text are the fractions. So it's really rarely there's like a integral value or something, like it's 1 or 2. There's always 2.5556784. Now, if you want to be pixel perfect, especially for the line spacing, stuff like that, well, you have to round, and this is the formula to round values to get the pixel perfect values of the floor around plus 0.5. I found it very useful, and yeah, it saves some time. One more thing, downloadable fonts. I don't know if you ever use fonts in UI application especially. So if you look Google for the how to use fonts, you will get the link to how to install fonts, and it will be something like go to the info list where you have to list all the fonts that you embed in your application, right? And this gives the impressions that iOS application only can use predefined list of fonts, but that's not true. Using the CoreText, we can actually download font, register that font, and used in our application since. And there are a few functions that help us with that. City font manager, register font URLs. That will register font from the URL. This is the file URL expected. City font manager register font descriptor. So first we create a descriptor, then we register. City font manager register fonts with asset names. This is iOS only. So if we have the font file in assets, we can use that name here and register that in a runtime. We can also use core graphic help here. First, load data with CG data provider, then create CG font instance, and then at the end use the core graphic city font manager register graphic font to register a font. And it's immediately available to your application, and you can use since. Yeah, but this talk was about the label. So where is my label? Actually, to write a label, there is a bit more. Given the information I gave you, you can actually write a simple label. That will be DrawTath layout, that text. You can add some fancy drawing around. You can probably add animation stuff. Well, you have all the ingredients that you may need to write a text. If you're interested more about the UI label, you can check the TTT attributed string. No, TTT attributed label. It's pretty old, but there's a lot going on with using the CoreText itself to draw the attributed string on the label. You can even use that to build the Swift UI kind of label. And yeah, so it's up to you to build a label eventually. But if you scan through the code I showed you, I'm sure you can manage to get one in seconds, maybe minutes. Thank you. This is everything. We have a short time to cover a really broad topic, so I hope you get the sense what you can do with the CoreText, how powerful it is, and how simple it is to use. It's not that hard to use, really. Again, if you have more questions, you can always reach me on Twitter, or just check my website. There's a projects I work on, and there's a contact information that you can use to reach me. Thank you very much.